Do you want to know an easy way to solve problems with rotation? If so, continue watching this video. So in this question right here, we're looking at finding the angular speed of the rotating object here from a force being applied on a string that's attached to it, causing it to displace 2 meters. So to solve this question, we need 3 things. The first thing is the conservation of energy, which means that the energy before is equal to the energy after. The second thing we're going to need is going to be the kinetic energy for rotational motion, which is given by this equation here. And then the last thing we're going to need is the no slipping condition, which means that this relationship here holds. So the linear speed is equal to the radius times the angular velocity. So we apply these 3 equations to solve this question. And to start, we can start by applying the first equation here, which is the conservation of energy. So before, this is going to be the situation when we initially apply the force. So when we initially apply the force, the kinetic energy of the rotating object is going to be 0 because it's not rotating. And the potential energy is also going to be 0 because it does not have any initial potential energy. So does that mean the energy before is equal to 0? No. This is because we were applying a force. From applying this force, we were giving energy to the system. So we're going to identify that the energy before is actually equal to the energy other, which just represents the energy due to the force applied. Now we can look at the energy after, which in this situation, we're still not going to have any potential energy. And the kinetic energy, this will be the energy of the spinning object due to the force. And so we can apply the third equation that we found for the kinetic energy of a rotating object, which is given by this. So if we equate the energy before to the energy after, we find this expression here. But what is this energy due to the force being applied physically? This is going to be equal to the work applied by the force. So if we apply the general equation for work, which is equal to force times displacement, we can replace energy other with this equation. So we get this expression here. And so we can isolate for the angular speed as so. And so this defines the angular frequency or speed due to the force applied. So we essentially just showed how we apply these 3 equations to solve problems like this with applying a force to a rotating object. So these 3 equations are keys to solve questions like this.